Thank you so much for staying with us in the 31 Symposium. For us, it's a pleasure. I start with the presentation. In this room, it's all in English because you have a translation in Spanish in another room.
Okay.
Otra traducción en español en una sala, lo tenéis anunciado todo en el programa. Si alguien quiere seguir la ponencia en castellano traducida simultáneamente, puede hacerlo en otra sala. We start with I present Ben Williamson. Ben Williamson, for us, is a pleasure to stay with us. Ben Williamson is a Chancellor Fellow at the Centre of Research in Digital Education at Edinburgh Fiters Institute and the University of Edinburgh. His research focuses on examining the ways educational futures are made and contested on the intersections of digital technologies, science, finance, and data with policy and governance. Williamson's current research focuses on educational futures making across a number of domains of socio-digital and data-intensive practice in three ways. First of all, the mobilization of biological science and socio-digital infrastructures of biometrics, neurotechnologies, and bioinformatics as resource of educational knowledge production, policy influence, and practice intervention. Secondly, emerging financial practice of speculative investment and market intelligence analysis in education, and how prospective invest and evaluations are intended to materialize social digital imaginaries in technical development. Third, the construction of large-scale data infrastructures by state agencies, global technology corporation, and edtech companies to measure race performance in schools and universities as a way of shaping and governing the future of education. He has published many interesting contributions, including Big Data in Education, the Digital Future of Learning, Policy and Practice, and is the editor of the journal Learning, Media and Technology. He maintains the research blog Codex in Education. First, thank you so much, Professor Williamson. And where you want, you can start. Thank you.
Okay. Buenos dias. Hola. Thank you very much for inviting me to this conference. I'm very sorry that we've not been able to meet in person in Valencia, as we hoped last year. I want to talk today about the future of the curriculum in the age of algorithms, data analytics, and artificial intelligence. Now, the curriculum that's taught in schools always faces two ways at the same time. So we both have a curriculum as a selection from the past that features knowledge that's considered valuable to pass on to the next generation. And a curriculum faces the future by introducing young people, our students, to knowledge and skills that are considered valuable in the years to come. And a curriculum also is developed and organized to reflect some wider assumptions about social, political, and technical change, and these things evolve over time. So in my time here today, what I want to begin addressing is what I think is the important question of how the curriculum taught in schools is being reimagined for a future of big data, algorithms, and artificial intelligence. So the talk revisits and updates some earlier research published as the report The Future of the Curriculum, which was originally written in 2013, so 8 years ago. And in that work, I examined how technical concepts, especially the concept of networks, and ideas about a network society were beginning to affect the way that different organizations thought about the school curriculum. So I was interested then in new curriculum design prototypes and programs that focused on ideals such as networked learning, problem-based learning, connected learning, and other approaches that were powered by and made use of the World Wide Web. And these prototypes of the curriculum of the future, as I called them, rejected the idea of a curriculum that faced the past and that was designed to conserve the social and technical status quo. This is what curriculum theorists have called a curriculum of the dead, that's based on selections of official knowledge, or the knowledge of the powerful, that represents the interests of particular political, industrial, and cultural elites. So instead, the prototypes I was looking at were trying to project a curriculum of the future that would anticipate social and technical change and prepare students to act in such a future. And then in my later work on big data in education, I went on to examine the new ways that education was being reimagined again in relation to wider data-driven thinking that was sweeping across all industries and sectors. So in the age of Amazon, Facebook, Google, and other data-driven industries, education itself has now become the site of renewed calls for curriculum reform and other changes. So new forms of official knowledge are now being demanded, such as knowledge and skills in computer code and data analysis, all with the aim of realizing a kind of future data society and the promises of alleged data-driven transformation. Okay, so the point of the earlier work on the future of the curriculum wasn't to make any predictions about the future of the curriculum, but it was to identify some particular ways of thinking about curriculum and curriculum change that were emerging alongside interests with the potential of the web for teaching, learning, and education. And we still see those kinds of interests in reports like this recent one here from the Connected Learning Research Network. So Connected Learning was dedicated to examining how learning occurs life-wide and lifelong through various media environments. So not just in schools, but in all the digital spaces and sites of cultural practice where young people gather, such as social media, media production sites, and online video games, for example. Now, this report states that today's digital and online media demand an approach to learning keyed to a networked and interconnected world. The growth of online communities, social and online media, open educational resources, ubiquitous computing, big data, and digital production tools mean young people are coming of age with a growing abundance of access to knowledge, information, and social connection. So in this connected learning program, we can see how the conventional idea of a curriculum as a course of studies centrally organized and administered, usually by ministries of education, and then taught in schools through formal school subjects, is rejected in favor of the idea of kind of decentralized webs of learning opportunities that extend far outside of the school curriculum to a much wider variety of other kinds of learning spaces. So connected learning as an ideal was then about drawing threads between these spaces to recognize the breadth of student learning in highly digitalized cultures and societies. Now, then, this reflected, I think, that the keywords of the first part of this century when connected learning was being founded and funded. The keywords of this particular moment were networks, decentralization, connections, flexibility, and communities, and other similar terms. These are the kinds of terms that were captured and analysed by Manuel Castells in the Network Society. But we now have a new technical vocabulary of data, or big data, of algorithms, analytics, automation, and artificial intelligence, and all of the social consequences that come with those technologies. And these consequences, it is argued now, include commercial exploitation of personal information for the creation of social graphs for advertising purposes, political micro-targeting, even persuasive so-called hyper-nudge techniques that are supposed to change people's behaviors. So Shoshana Zuboff has now quite famously called this surveillance capitalism, and argues that it extracts business value from the raw material of human life and then seeks to change human behavior to generate even more value for data-driven businesses. And there's some question about some of the arguments along these kinds of lines, but I certainly think we see some of these developments playing out in perhaps slightly less spectacular ways than is sometimes presented in the media. So for at least around the last 10 to 12 years, we know now that big data have become central to a wide range of social, economic, business, and political activities. Social media companies are collecting user data for advertising. Businesses collect big data to identify commercial opportunities. Governments need big data to understand the public, its sentiments, and perhaps even their voting intentions. And increasingly, the focus for today, the education sector has now become fixated on big data algorithms and data analytics too, in order to assess students, staff, schools, even entire education systems in an increasingly granular, microscopic, real-time fashion. Now, this data revolution, as some people call it, arrived just as my report on the future of the curriculum was being published. And I still think that the long-term implications for education in general and the school curriculum in particular remain to be fully studied. But the general idea that advanced technologies might affect how we design and deliver or implement a school curriculum were anticipated at least, well, nearly 30 years ago by Howard Gardner, more famous for his multiple intelligences work. And Gardner suggested in 1993 in an article for the Demos think tank in the UK that the school of the future might have the student curriculum broker to help match students' profiles, goals, and interests to particular curricula and to particular styles of learning, he argued. And then he said, new interactive technologies offer considerable promise in this area. It will probably be much easier in the future for brokers to match individuals to match individual students to ways of learning that prove comfortable for them. We now have the technological and the human resources to implement such an individual-centered school, Gardner argued. Now, I think some important aspects of this include this idea of matching students to appropriate curricula according to their profiles, assisted by digital technologies, and then individualizing their learning experience. I think this is significant in terms of ways we think about what a curriculum is, what it's for, and how we enact it in practices. And also note here that Gardner, in 1993, seems to be talking of a student curriculum broker who is a human being whose ability to match students to curricula and to modes of teaching might be helped by digital technologies or assisted by digital technologies. But in 2021, our current context, Gardner's ideas about a student curriculum broker now appear to be becoming something more like a robot. Intelligent machines driven by artificial intelligence, say some educational thought leaders, are going to transform schooling by individualizing and customizing students' experience of the curriculum based on tracking data about their progress in real time and matching them to appropriate resources and materials based on their profiles. This is the same idea of a student curriculum broker, but now with added automation. And we now call this sort of approach learning analytics or AI in education, and a cluster of similar type approaches. So the student curriculum broker, imagined by Howard Gardner, is now being programmed in to learning platforms that are designed to harvest thousands of data points from students' digital learning activities, then deploy predictive algorithms to assess their likely progress towards particular outcomes, and then adapt or personalize the curriculum experience automatically based on the students' data profiles. So with these kinds of data analytic based approaches, we see another step, I think, in ways of thinking about the future of the curriculum. No longer is the curriculum based on the knowledge of the powerful, of political, cultural and industrial elites, which has been selected for transmission to the next generation, nor is it about wider social and cultural networks of connected learning beyond the school. Instead, it's about powerful computer machines producing new knowledge about students, from tracking their data and then adapting the course of their studies according to ongoing assessments and profiling of their academic performance, progress, and other measures of their learning and skills. The curriculum itself in this model is imagined as being reorganized as personalized learning pathways, or even playlists based on the recommender systems of Amazon, Netflix, and Spotify. And it was, in fact, in Silicon Valley, the global heart of the techno-economic revolution in California, in Silicon Valley, that the most ambitious attempts to redesign curriculum, and indeed the whole institution of school, have taken place. And I want to give some examples of some curriculum prototypes of this kind of algorithmic AI, big data driven future of the curriculum. So what I call here startup schools are experimental new school institutions that have been established by Silicon Valley technology entrepreneurs as models for the future of schooling. They take the model of the startup technology company, very common in the tech sector in the States and across Europe, and apply it as a model to education, startup schools as I call them. Now, among these startup schools are Summit Schools, which is a charter school chain based in the United States of America, which has been heavily supported by Facebook founder Mark Zuckerberg. Now, Summit uses an adaptive, personalized learning platform that was originally built by Facebook engineers to track and monitor and assess students constantly. And the platform is now used in hundreds of schools across the States, despite a wave of student and parent protests only a couple of years ago that you can see on the slide here. Amazon's Jeff Bezos is establishing a new chain of primary schools as well, focused on what he calls optimizing the customer experience with digital technologies. The child is the customer, he said. Elon Musk of Tesla has set up a school called Ad Astra within his SpaceX initiative. You know, his plan to go to Mars has a small school attached to it. Now, most of these startup schools also reflect the wider involvement of these technology entrepreneurs in education. They don't just set up these startup schools, they have much wider interests that these schools, I think, condense and concentrate and exemplify. So a lot of these entrepreneurs push for data-driven, personalized education, as they call it. And these startup schools reflect as well their interests in science, technology, engineering, and maths, the STEM subjects, as the most important aspects of the curriculum too. Now, these entrepreneurs are not educational or curriculum experts. They're technology founders with their own visions for the future of education. And these are visions in which the technologies that gave them their fortunes are now seen as essential to reforming education and the way that the curriculum is organized and implemented. And these entrepreneurs are now becoming like figureheads of a new major global reform movement, producing prototypes for the future of schooling, teaching, and curriculum organization. Now, just to give another example of a startup school, I think alt school exemplifies what's going on here. And also some of the complications and controversies that are arising in this space. So alt school was originally set up in San Francisco before extending elsewhere. It was originally set up by a former Google executive as a chain of micro schools with its own in-house educational software development lab. And it received $174 million in venture capital investment from Mark Zuckerberg and from PayPal founder Peter Thiel and a range of other Silicon Valley investors. And it described itself as a lab school, a laboratory school, or a laboratory for new forms of teaching, learning, and curriculum organization. It was all going to be based around a learning platform that would serve up so-called learning playlists to students based on constant ongoing assessments. It also claimed it was setting up cameras and sensors and microphones in the classroom in order to detect social interactions from students' physical movements and the emotional aspects of learning from students' voices and even from their facial expressions. So its ex-Google founder claimed it was inspired by the progressive education movement and especially Montessori schooling. So this was a kind of alt school was a model of high-tech, data-driven, child-centered education in the cloud with loads of data analytics running constantly in the background. But then alt school started falling apart. This experiment was ultimately a huge failure. Parents started pulling their children out. The media started asking questions about its software model. Academics worried it set a template for further privatization and commercialization in education, with private companies not just providing services to schools, but actually now creating schools and determining the curriculum to be taught with opaque, untested technologies. So by 2019, Alt School had sold off all its schools, and it then rebranded as an EdTech software development company called Altitude. So the schools, it seemed now, had just been laboratories for software development and testing. The students had just been guinea pigs or lab rats in a great education technology experiment in personalized learning. Even more recently, Altitude, the software company that was left when the schools were closed, then recently sold its own software platform and its engineering team to another group called Higher Ground Education. This is another chain school organization dedicated itself to Montessori-inspired education, and it also brought up many of Alt School's original micro schools to extend its own reach. So, despite the student protests at Summit, and despite the collapse of Alt School as a startup schooling model, the underlying model of personalized learning with data-driven, adaptive platforms that they prototyped and tested in these micro school settings now lives on. And I like to think of, I like to call this algorithmic progressivism, a kind of form of student-centered education where the student is known intimately and individually from algorithmic analysis of his or her data trails, and where learning is understood as an engineering problem to be diagnosed and then optimized with technology. And where software engineers and investors have significant influence. Now, my use of the word engineers and investors here is quite deliberate, because many of the prototype forms of education developed at Summit, Alt School and elsewhere are now being further developed and funded by a variety of engineers and investors. So software engineers are now building new technical systems for delivery of education, and investors are funding them with millions of dollars of private capital. So the visions of the future of the curriculum of these engineers and investors are therefore highly influential, because they have the technical power and capacity and the wealth to make them into a new reality of schooling. And this is especially the case in the area of research, development and application, which is becoming known as learning engineering. Now, learning engineering, as it's described, represents a combination of the computer and data sciences, including artificial intelligence, with the learning sciences and learning analytics, which are also based on cognitive, psychological and brain sciences. Plus, on top of that, learning engineering requires software engineering design methodologies. So the Institute of Electrical and Electronics Engineers, this is the world's largest and most influential organization for computer technologies and engineering, is currently hosting an industry consortium on learning engineering to develop these approaches, scale them up and extend their reach into new settings. Now, according to this consortium, learning engineering is a process and a practice that applies the learning sciences using engineering design methodologies and data-informed decision-making to support learners and their development. So it involves, they say, instrumenting classrooms for data collection and analysis, including in some cases by using sensors and other instruments to track student movements, for voice tone analysis, and facial detection technologies for tracking students' emotional engagement with the content being taught or the curriculum and the mode of instruction of the teacher. So we can see this consortium, I think, as a really sort of powerful group that will define the ways that certain aspects of artificial intelligence and adaptive technologies, learning analytics, and other forms of data-driven teaching will be engineered into the technologies that will be used by schools for years to come, potentially. But this is not just an academic enterprise. Learning engineering has not just appeared from R&D labs of research-intensive universities in the States, although it is very popular at MIT, Carnegie Mellon, Stanford University, and so on. But the most significant promotion of learning engineering is, again, surprise, surprise, from Silicon Valley. And especially so through the philanthropy and the investment programs of Facebook's Mark Zuckerberg and ex-Google chief executive Eric Schmidt. So the Chan Zuckerberg Initiative's director of learning science, for example, has said that learning engineers will gather and analyze evidence at multiple scales or multiple levels, from click streams, motion position data, speech streams, gaze data, biometric and brain sensing, to more abstracted feature sets from all of this evidence combined. And then using it, he argues, to identify new opportunities for targeted intervention and precise action in ways that he says are similar to precision medicine in the biomedical field. Now, the Chan Zuckerberg Initiative has already put millions of dollars of philanthropic grants and private investments into programs and companies developing these kinds of approaches. Eric Schmidt, former chief executive and chair of Google, has his own investment program called Schmidt Futures, and that also recently awarded $2 million to projects specifically developing learning engineering approaches. And it did this in partnership with the global investment and financial services company Citadel as part of its Futures Forum on Learning. So if we want to understand learning engineering, which I'm suggesting is potentially going to be quite powerful as a movement in defining how data analytics, algorithms, and AI are deployed in education. If we want to understand learning engineering, we have to see it as a mixture of the multidisciplinary learning sciences, which also brings in cognitive brain sciences and other aspects of psychology, along with some biomedical ideas about the biological basis of learning. It also brings in the data and computing sciences. It brings in AI expertise and engineering methodologies. And it also brings in private sources of both philanthropic and investment finance and capital. And all of these things combined together are now producing powerful visions of how data analytics, algorithms, AI, adaptive learning, learning analytics, personalized learning technologies and platforms, how all of these things might transform education, curriculum, pedagogy for the future. Now, most of the examples that I've described so far indicate how the curriculum of the future is being reimagined in relation to contemporary big data algorithms and AI, but for the most part, these developments have remained largely in prototype or experimental form in places like the lab schools that I've described, or the R&D departments of education technology companies, or in the kind of working groups and consortia of researchers and developers that I've just outlined. Then last year, of course, COVID-19 happened. And with this shock of the pandemic, for many organizations and individuals who are investing in these ideas of big data analytics and so on in education, for these groups, it seemed like the future had arrived all at once. Whole education systems went online, demand for educational technologies and soared. In the media, this was presented as the greatest edtech experiment in history. The OECD's director of education claimed it was a great moment as innovation in digital education and data-driven education could finally be unleashed. The mass migration of students to online and other digital learning platforms also meant that unprecedented quantities of data could now be produced and analyzed. Commercial education technology companies expanded their market by making services free or heavily discounted. Now, there's far too much to say about this kind of edtech pandemic shock, and Anna Hogan and I have tried to capture some of it in two recent reports for Education International, if you want to read more about that. But just for the remainder of this talk, I want to focus on two important examples that I think help us to understand how there's been a movement from the kind of lab schools prototyping a curriculum of the future based around data analytics, AI and algorithms, building then with these ideas about learning engineering, and how the COVID context has accelerated some of these developments and begun taking them to a much larger scale with deep significance, I think, for the ways in which the curriculum in schools is going to be designed in the future. And the two examples I want to give are Google Classroom and the rapid escalation in education technology investment. Okay, so probably many of you are familiar with Google Classroom. I spent an awful lot of time on it over the last year while my children were studying from home, and I imagine many of you did too. But Google Classroom is, simply put, is Google's platform for online education. It's part of the wider G Suite of apps that Google recently rebranded as Workspace for Education. And Classroom allows educators to set up assignments, students to complete them, and it also integrates with hundreds of other third-party education technologies. Now, during the COVID-19 pandemic of the last 13, 14 months, Google experienced a huge rise in user numbers, up to a reported 170 million worldwide, according to the last reports I heard. Now, this is largely due to it being free. So schools in need of a learning platform while children were unable to attend school in person found Google Classroom to be a very beneficial platform, given that it had no budgetary constraints. In the UK, our government also funded advisors to work with schools to set up schools to use Google Classroom or the alternative Microsoft product. So Google Classroom has massively increased its customer reach, and in doing so, it's also massively increased its data gathering capacity, because Classroom facilitates the extraction of data, information from every interaction with the platform and all of its third-party add-ons any interaction made by students or teachers with it. Now, for many, many years, there have been big questions asked about what Google does with all that data from its educational apps and platforms. And it's always been shady about answering those questions, but at least one of the things we know it does is it uses this freely supplied data from schools for product development. So it takes the pulse of schools through the classroom. What are teachers and students doing on the classroom? And it then uses those insights to refine the platform and to develop new features and upgrades, and to then extend its reach by reaching into more and more functions of schooling. Another question that's been asked about Google more recently is what would happen once schools fully reopened? Would all of these schools that had moved to classroom continue to use it? Would they drop it? Would they build it in to their ongoing approaches, even when all children had returned? Now, the answer, it seems, from recent Google announcements, is that it's analysed the data it's collected over the last year, and it has now identified that schools are using Classroom much more like an integral learning management system. Now, Google has always maintained that Classroom was not a learning management system. It was not a freely available competitor to, say, Canvas or Blackboard or Moodle or all the rest of them. Classroom was a simple platform for online delivery of assignments and so on. However, in the recent announcement that I've just screenshotted on the screen, it was announced that Google's now begun releasing new upgrades to Classroom to make sure that it functions explicitly as a learning management system that schools will continue using for the long term once all lockdown restrictions have been lifted. It says, we never planned to be an LMS. Schools are using us like an LMS, so therefore we are redeveloping the platform so it acts like an LMS. The central technological kind of infrastructure that schools will use for the long term. So now, with some recent upgrades, Classroom can be synchronized with class registers and student information systems so that it's integrated with schools' existing data systems. It's expanding the marketplace of third-party add-ons, so schools won't ever need to leave the classroom to access other products, which will all be available with a single Google sign-on. Grades and from different platforms and assessment services can be integrated too, so students' entire academic performance is visible through the classroom. And it started to provide increased student data tracking facilities for teachers, leaders, and system administrators to monitor student engagement and progress. So Classroom is now a global learning management system hosted on the Google Cloud with reach to approaching 200 million students worldwide. That gives it huge data gathering powers, and it also has clear ambitions to keep upgrading the platform with new functionality, and it also gives it a major gatekeeping role as the centralized platform for accessing other third-party education technologies. It's also proposing to introduce a tiered pricing structure so that many of the schools that adopted the Classroom for free may have to begin paying for its services. So we see these earlier prototypes developed at places like Alt School are now being scaled up through the Classroom to millions of students worldwide. If Alt School was a small-scale lab experiment, Google Classroom is seemingly a global experiment in digital, data-driven schooling. And Google doesn't say much about curriculum specifically in relation to Classroom. Its focus, like most of the tech industry, is on improving learning. But we can see, I think, how classroom would affect the organisation of school knowledge too. It seems to reduce school knowledge to measurable skills or to pieces of content that might be acquired across a market of digital suppliers and then assessed and reported through the power of Google's global cloud architecture. I want to just give one final example. I said I wanted to talk last about investment. So investment in new models of education has also risen dramatically over recent months. So the global EdTech market intelligence agency HolonIQ recently calculated that over $16 billion was invested by venture capitalists into EdTech in 2020 alone. And this, it said, was funding, backing a vision to transform the way the world learns. So financial investment in education technology seems to have two complementary aims. First, quite straightforwardly, it's about seeking future value from having a financial stake in a company that is considered to generate, likely to generate future profit, so that the investor gets a return from that. But second, it seems to be about investing in a particular vision for the future of education, and a future in which that profit is more likely. So investors are, I think, crucially important in education because they fund the particular types or models of education that then become possible and are realized and are rolled out into schools. You need the funding to extend reach. Google has huge wealth to do so. Most other education technology companies rely on investors. And that investment has been rolling into the education technology industry at unprecedented rates over the last year. So in financial language, investors are making bets on certain futures and perhaps shorting others or other futures. Investment makes certain futures of schooling, curriculum, teaching and learning possible, and not others. And what futures are EdTech investors currently betting on? So in its global learning landscape, HolonIQ, again, has identified over 1,000 education technology providers that it says characterize the future of education. And these companies have been assessed by HolonIQ, both on their potential for innovation in education and their prospects for profitability and the promise of return they make for venture capital investors. Now, the emphasis across this landscape graphic and a whole report that it's based on is on organizations that deliver digital education services that are largely based on the extraction and analysis of student data, increased personalized learning, and the extension of machine learning algorithms and AI to more and more aspects of schooling. So this global learning landscape powerfully represents a certain future of highly digital, data-driven education. It's attracting investors to put their funds into this particular vision to generate shareholder value, while at the same time suggesting to institutions that they should make their own technology procurement decisions based around this vision too. Now, as you might be able to see from the first column of the landscape, one of the key categories here is knowledge and content, with curriculum as one small subcategory of that in the middle. So this is the idea of a curriculum as a very small component of what happens in education. And it's a curriculum mediated by commercial platforms that are seen to be good bets for investors. They also seem to represent the idea that the curriculum is something that can be kind of unbundled to a market of third-party product providers. Now, what I've aimed to highlight in this talk, and I hope it's been useful, is that the kind of future we imagine for the curriculum tends to reflect wider social and technical developments. And 10 years ago, the school curriculum was being reimagined in terms of networks and connected online learning. The connected learning movement rejected the idea of a curriculum that represented a formal selection of the knowledge of the powerful, and instead it highlighted young people's digital cultures as sites of informal learning. But now the dominant vision I've tried to scan out in this talk seems to be more focused on the idea of curriculum customization, with automated student curriculum brokers matching individuals to appropriate knowledge based on constant real-time monitoring of their data, and then the application of adaptive personalized learning platforms and playlists as increasingly automated modes of teaching. So the knowledge gained by so-called intelligent machines about students seems now to be just as significant as the knowledge selected for inclusion in a school curriculum itself. But this is a future being imagined and developed by technology entrepreneurs, by big tech companies, investors, researchers and developers of data-driven teaching and learning. And they represent just one part of wider education systems, and we may want to question how these kinds of organizations have become so significant in imagining the future. If the major critique of many curriculum theorists over the past 50 years is that a curriculum represents the knowledge of the powerful, the usually political, cultural and industrial elites, which determine what kind of official knowledge gets taught in schools, then we now need to more deeply interrogate the new powerful actors that are seeking to shape the whole system of schooling. Their emphasis is on personalized modes of instruction based on algorithmic analysis of student data, content delivery by the market of content and knowledge suppliers, and alignment of curriculum to the skills demands of an imagined future. They make algorithms, data analytics, and AI into powerful, automated student curriculum brokers with the power to match students to appropriate curriculum materials and to radically change the future of the curriculum itself. Now, just very quickly before I finish, it is, however, important to note that last week the European Union published a proposed regulatory framework on artificial intelligence, which will control the way that artificial intelligence is used across the continent. And this proposed framework includes some significant prohibitions or bans on certain aspects of AI. And those bans include public facial recognition and social credit systems. But just below the bans, the kind of the worst offenders according to this European Union proposal, there's also a number of areas of AI development that are considered to be high risk. And education is specifically in that category, particularly systems that use data algorithms and machine learning for assessment, which might, the EU regulation says, change the course of students' lives and their future opportunities. Now, it's going to take years for the European Union to finalise this proposal and ratify it, and for it to, be put into action. But it seems likely, from what's been proposed, that organisations developing AI-type approaches for education will, in the future, need to register on a new EU database before they're able to supply their services or products. They may even be subject to new forms of monitoring, reporting, and regulation, with the threat of significant financial penalties. So, just to wrap up, it seems the future of the curriculum being imagined and developed by many of the organisations I've mentioned here could be considered, according to this framework, very high risk. The EU proposal puts AI in education and related approaches using algorithms, machine learning, and analytics, puts all of these technologies under the lens for new regulatory inspection and scrutiny. And it highlights how the future of education and the curriculum in the age of big data and algorithms and analytics and AI needs to be much more carefully examined by education researchers, by privacy and ethics experts, by policymakers, regulators, and other stakeholders before it becomes the risky reality of everyday schooling. Thank you very much for your time this morning, and I hope I've left enough time for some questions and discussion. Thank you.
Thank you so much, Professor Williamson. Thank you so much for this interesting conference, for this opening conference on the Symposium. Now it's time to make questions. We use this platform, Blackboard Collaborate, to make these questions. I changed to Spanish. Si alguien tiene alguna pregunta o alguna cuestión, como ahora hemos puesto en el mensaje de chat, puede levantar la mano y le autorizamos a hacer les autorizaremos con permisos para poder formular la pregunta. Puede hacerla en castellano y la traduciremos, o en inglés y directamente. Hacemos varias rondas. We make rounds, 3 rounds or 4 rounds of questions, and Professor Williamson responds all together. Okay. The way is, la gente que quiera puede levantar la mano y formular la pregunta. También me están enviando preguntas desde la sala de traducción. I have one question, Professor Williamson, in my case. The question is what response as we as educators we can give to this kind of wave of big data in the curricula, no? What response can we that about this phenomena, no? Because we are there are teachers, there are the people in the symposium, and it's possible that the response is not only from educators. It's the way it's. I suppose that it's that consumers too. I don't know, but what response can we that with this phenomena that you say in your conference?
Yeah, so I think that's a really good question, and I think the European Union regulation is a good prompt for us to think about what other ways we might want to respond as educators. So regulators have their own particular concerns, but I think we also need to come up with some specific educational arguments in response to some of these technologies. So it's interesting, for example, that over the weekend also UNESCO launched, it was another European Union program, launched a consultation on the use of artificial intelligence in education, and is currently asking for participants to get involved from across Europe. Because I'm based in the United Kingdom and Brexit, I'm unable to participate, but I would encourage European colleagues to follow up on that in order to have their voice heard. As I've tried to articulate in the talk, there seems to be some particularly powerful voices and networks and groupings that are coming to some kind of shared visions of what education in the future should be like, based around the deployment of data analytics and so on. But educators start from quite different perspectives. We don't start from the perspective of what the technology can do. We should ideally be starting from the perspective of what are our values and what kinds of purposes of education are we pursuing. So I would suggest that as educators we try to get involved with these more public consultations, such as the one that the European Union has just opened, but approach those consultations with these bigger questions and issues about purposes, values and aims of education. Now, of course, those aren't easy issues themselves. I mean, the ideas about what aims we have for education are deeply contested, but that, of course, is exactly as it should be. In a more democratic world, we invite multiple stakeholders to discuss and deliberate and come to some kind of shared agreement about the mutually beneficial best way forward. My sense is at the moment that isn't happening so much, that this kind of data-driven approach is being imposed. But educators should be trying to engage with some of the significant organizations that can themselves make a difference. So the European Union, the UNESCO Futures of Education initiative, which is ongoing at the moment too, are both really good examples of spaces where sort of dialogic conversation and deliberation over the future of education and the role for AI in those futures should be discussed.
Thank you so much, Professor Williamson, for that your response. We continue. There are several questions from the translator room. We can aggregate the question in a one round. I change to Spanish. Saben que pueden utilizar la mano que aparece en la parte inferior de sus pantallas para que les autoricemos tanto a usar el chat como hacer una pregunta. Tenemos algunas preguntas que han llegado desde la sala de traducción. Ahora las agruparemos en una única ronda. María Sabiote tiene la mano levantada. Vamos a... ¿Puede, señora Sabiote?
Hola. Sí, hola.
Sí. Si quiere la puede formular en español y se la traduciremos junto con la otra pregunta que se ha formulado.
Bueno, lo voy a intentar en inglés. Thank you very much for your key conference. It has been a very interesting. Sorry, I have my baby crying. Can I have a question later, please?
Yeah. No problem. You can make your question later. There are questions, Professor Williamson, in the translator room from Manuel José López Martínez that say that I would like to add to, in this scenario presented for you, for Professor Williamson, the Silicon Valley gurus take their sons and daughters to analog schools outside the influence of artificial intelligence. It's a paradox. How does the professor see it? How do you see it? This paradox, this kind of paradox. And there are another question from Antoni Santisteban that say that algorithms offer you what you want, but not what you need. If I enter right-wing extremist content, the network offers the right-wing or fascist content. Big data is perfect for sharing, but for learning it would be necessary to question our conceptions and not to enhance them. Therefore, in social science, it does not don't help to form critical thinking. Is the opposite, isn't it? If you want, I try to write in the chat too. And Maria Cristina Nin from in the translator room says that, what do you think about the situation in Latin America? Thousands of children not attending school, the increase in poverty, the online classes increase the poverty in Latin America. Okay, you can respond wherever you want.
Yeah, so it's a really interesting question about how technology entrepreneurs and so on claim that they don't let their children use iPads or attend schools which are heavily technology led. So I think there's something intriguing going on here, which is about a mixture of quite progressive ideas, for example, linked to the Montessori movement, or even to ideas from Steiner schooling about, you know, extremely kind of low tech approaches to schooling, which is then being mixed together with these entrepreneurs' more sort of techno optimistic visions. And that's, I think, you know, something to unpack and explore more to help explain exactly what they're trying to do in education, because, you know, many of them are talking in, you know, in language which is all about social mobility and addressing inequality and so on. And most of us are quite skeptical of that. But I think we need to look at the kind of knowledge claims and some of the kind of the philosophies they're drawing on to try and understand specifically the claims they're making. I'm aware that there have been some questions about whether Silicon Valley founders genuinely do withdraw their children from technology-centered spaces. I've also read reports that some send their children to places that are more based around the model of maker spaces. So schools that seem focused more on kind of Seymour Pappert's notion of constructionism and actually fiddling with physical, tangible objects, as well as with kind of computer code and so on, to build new kinds of products. So I think there's probably a mixture of different things going on within the Valley itself. And of course, some of this is also mixed up with what seems to have become quite a trend of Silicon Valley tech sorts having some kind of moment of revelation about the potential damage that's being done in the wider world from the kind of technologies they've developed. So I think there's a whole bunch of interesting things to untangle. The question about algorithms offering what you want and not what you need is, I think, a really important one. Algorithms of the kind that are being deployed in most of the technologies I've described here are based on capturing past data from individual students and their present data and using that to extrapolate from the future, and then identifying particular kind of, you know, sort of linear pathways through particular content and material to get there. And in some respects, this idea of personalized learning as developing these sort of predictive pathways is very much sort of based in the more kind of the technical science, technology, engineering and maths subjects, where it might be that there is kind of some kind of conceptual mastery going on. I find it harder to think how that would work in a more kind of humanities and social subject kind of field. But yes, absolutely, there are issues here with algorithms simply prescribing more of what has been assessed from the past and then preempting futures and narrowing and channeling the possible pathways that young people might encounter, rather than opening up a variety of different kinds of experiences and with all the unexpected new kind of opportunities for learning that might emerge from that. Perhaps even more dangerously, of course, if we base a lot of these analytics on past data, then it involves comparing the individual to a mass of historic data. And if that historic data is, whether by design or not, full of particular biases against particular groups of people of color or children from particular class groups, and those particular biases in the larger data set are then used to make discriminations about the individual who is currently interacting with the system, then that might result in a kind of lowering of expectations and a directing of a student on a particular kind of lowered pathway, rather than one that's more challenging and might lead to other kinds of outcomes. And in a quite a straightforward way, we saw that happen in the UK last year with historic data about students' exam grades being used to standardize the grades that teachers had given students, so that we saw thousands of students find their exam grades reduced, which meant many had their offers for university withdrawn. So these are historic biases in the data that are then used to make hugely significant, life-changing decisions about young people based solely on numbers. My sense is it's examples like that that has catalyzed the European Union to intervene and say, actually, we're going to put AI-based assessment, because that's exactly what it does. We're going to put artificial intelligence assessment on this high-risk group. There was a final question, I think, in that group there about critical thinking and a kind of reduction of the possibilities of critical thinking. I think I'd go along with that. That education through algorithms seems to be based more around the idea of acquisition of particular kinds of skills that are discrete and measurable. So there's a kind of a reduction of what we would describe as a coherent curriculum to simply a kind of constellation of skills that need to be demonstrated by a student on a platform, and it's demonstrated then by being measured. So these have to be measurable skills. That does appear to close down opportunities for the development of the more kind of critical skills that are required for young people to develop as informed citizens for democratic forms of citizenship. And again, my sense is those are the kinds of arguments that particularly UNESCO's work on education futures has begun to engage with. And I think as educators, we need to, just to reiterate, I think we need to engage significantly more with these larger organizations to make sure that these are the kind of arguments that are really being heard at a political level, because I'm not sure we can entirely address them simply through our own institutional.
Okay, thank you, Professor Williamson. There I have two questions more that from the translators room. And Maria, if you want, you can make your question, and later I explain the 2 doubts from the translator room.
Well, my questions were very, very similar to the ones that Mr. Williamson have already addressed. So yeah, they were about my concern about the extremely biased algorithms. Algorithms are biased by gender, especially by gender and by race, and we know already. So the expectations algorithms have about the students are extremely mediated by this bias, as Mr. Williamson has said. And so as an educator, I'm struggling to have my student exposed to different sources of information, because actually the devices they have at home are extremely, the algorithm have already set a very particular path of information. So I have been always an early adopter of technology, but I think that I have to come back to books. I mean, I remember last course I asked my students to get information about the Wild West, the American Wild West, and all my students came back with information about the Game of Thrones. On the and for me it was like, how is that possible? So if I think we have to come back to books, actually. And I don't know what Mr. Williamson will think about this. And I think we have to rethink digital competence, because I think for digital competence to be a real competence, we have to come back to books, even if it's paradoxical. Thank you.
Thank you very much, Maria.
I'm sorry, a related question that Maria in the translator's room is from Nicolás de Alba from Universitat de Sevilla. He says that at the first glance, it seems that this kind of digital education proposals are at the antipodes of critical and citizen education because of how they are financed and the way they work. Do you think they could be used anyway to educate citizens in critical thinking? If so, in what way? And Neus González Monfort from UAB says that, how do you interpret the fact that the public interest is not the majority? She says that it's the private hands of large corporations, of an elite, of a minority, of a sector of population that has not been democratically elected, and therefore does not have to represent society. This is a problem that it's only few hands. And what is your opinion about that?
Okay. Okay, so just to return to Maria's question first. I mean, I think we need to, and this is the kind of work that someone like me that's working in this field, needs to do, is articulate very closely and carefully how some of these issues around biased algorithms, particularly around issues of gender, race and class, are enacted through the particular technical systems used in education. We have very, very little documentation that this is taking place. So, in some respects, we should be circumspect and not jump to conclusions. But also, as we've seen in the British exams example, as I've already indicated, we know that these kinds of things can happen. And we see them happening already in the technical models in the wider kind of social media sphere, and where they're being deployed in other aspects of the public services, such as in health and in social welfare allocation and in law and justice and so on. We see these kinds of injustices emerging in all of those spaces already. So the work of educators in this space needs to be to very seriously document the issues of bias and discrimination and other forms of kind of automated discrimination and so on in our own field. Chris Gilliard, who's an educator based in the States, has done some really important work on what he describes as digital redlining. So you have the old idea of redlining as kind of drawing on a map of areas which would then be excluded from particular kinds of services. And this has a long history in the States in particular. And Gilliard's argument is that digital redlining works with a similar kind of logic, that you use the profiles that are made of technology users to then either include them or exclude them from the provision of particular kinds of services. And his argument then as an educator is that and female students are systematically excluded from particular forms of knowledge or curriculum content and materials based on profiling that is done about them in the system. So this idea of digital redlining in education seems to me an absolutely crucial concept to explore, and should sort of galvanize us to do the empirical work to figure out how this is happening, or where it is happening, and whether it's happening through our education institutions and practices. There was a question about whether some of these technologies, algorithmic technologies and so on, might be used to reinforce or support critical education and citizenship as I understood it. And there's some really interesting work coming out of the wider field of kind of critical algorithm studies, and particularly some legal scholars who are writing about the legal aspects and the political economy of algorithms. So Marianne Fourcade and her colleagues, for example, argue that we probably can't expect technologies of big data, machine learning and AI to go away anytime soon. But what we could do, if we formed into sort of powerful groups that included social scientists and legal scholars and ethicists and technologists and so on, we could find other ways of repurposing these technologies or designing them differently. And the key argument that Marianne Fourcade makes is that we need to design from the perspective of those affected. And I think that's a powerful statement about the way we might approach these kind of technologies. Not in a kind of Luddite, we just need to get rid of the whole lot, but from a more kind of proactive and productive perspective of, here are all of the problems with the current model. How can we design from the perspective of those who are going to be affected by these technologies, which in our case is students and teachers, and indeed whole institutions which might be assessed. I think there was a final question there about the kind of visions I've described being those of sort of powerful groups that are not democratically elected. It seems to me that's probably a really huge sort of political and policy question. My approach as someone who, I think of myself as somebody who does policy research alongside the technology research, is that we've seen over the last probably 10 to 15 years the development of a range of really powerful and strong sets of alliances that stretch across different sectors, that involve governments and government departments or ministries of education, but they also involve large-scale education businesses, small-scale startup technology businesses, the large sort of intergovernmental organizations such as the OECD and the World Bank and so on, and that a shared consensus has been developed by these organizations about the kind of future of education that ought to be and should be pursued. And Anthony Verger, who is based in Barcelona, I believe, writes about the global education industry as this kind of increasingly mobile, international set of networks which promote and support these kind of transformative and reformatory visions for education. And Verger and his colleagues, in a book specifically on the political economy of privatization of education, which was published about 5 years ago, have a really significant chapter on education privatization during emergencies. And they're writing specifically about New Orleans after Hurricane Katrina and education in Iraq after the Gulf Wars and so on, and how privatized education reformers use those emergencies as opportunities to push their models of reform. I think we can see our current moment as just another example of a kind of pandemic situation being exploited as a kind of catalyst for more privatized type reforms. And these reforms are being promoted not just by private sector businesses, but by these kind of constellations of organizations across a global education industry that includes consultants, it includes technology companies, it includes the OECD, it includes ministries of education too. So I think we have a really complex set of issues around the whole kind of the politics and the commercial and the multi-sector ways in which education futures are being imagined and promoted at the moment. And it was teasing out some of that complexity that Anna Hogan and I tried to do in our 2 reports for Education International, if you want to look a bit more into that.
Thank you so much, Professor Williamson. We have time for our last question, if anybody have another question too. But we have a last question that is from our partner, Paula Jardón from the University of Valencia. She says that this type of learning seems more suitable for learning procedures and close content, but not for dialogue, interactions between equals. Do teachers, she says, do teachers have access to their students' data and their reactions, or is the application the one that makes the decision in the educational actions?
Yeah.
Do you understand?
So, yeah. So in most cases, we are not yet at the stage where we have full automated assessment or analytics going on of students. So most of the developers of these technologies will say we are not trying to take away teachers' important role, we are augmenting the role of the teacher. In many ways, that seems to me just as significant. If we now have these kinds of organizations seeking to augment the professional role of the teacher, then that is going to raise all sorts of issues around how teachers practice their craft, the kinds of pedagogies they employ, and particularly the way that teachers can become quite discriminating about the kinds of decisions or recommendations that these technologies are making to teachers. Now, of course, in some cases, some of these technologies are a bit more automated. So the examples I gave of the kind of the startup schools in the US are very much about the application, processing data about a student's progress on a daily basis, and then generating these kind of playlists of recommended material or content. So although these schools certainly aren't fully automated spaces, they do suggest an increasing degree of automation within the classroom, which affects all of the major aspects of schooling. It affects how teachers teach, the kind of the pedagogy or the instructional method, as they call it in the US. It affects the curriculum in terms of thinking of a curriculum as something that's sort of coherent and organized and organized in a spiral fashion, so students encounter increasingly complex arguments and concepts, so on. And it affects assessment as something that it appears can be more efficiently done through technology. And often the argument is that actually assessment can be done in a way that's fairer, because there's significant evidence that human marking has all sorts of problems attached to it. Though maybe AI isn't the solution to that. Maybe we should just support better human marking through other means, perhaps. So I don't think we're at the stage yet where there's complete kind of decision making at the level of application. But the important thing is, how do we work with teachers then to enable them to work with these kinds of technologies in a more sort of critically informed and discriminatory way? Or do we do what I was trying to argue earlier, which is about something that's a bit more systemic, working with perhaps organizations like UNESCO or the European Union to figure out different ways of designing educational technologies that work from the perspective of students and teachers, rather than starting from the perspective that these technologies can do these kinds of things and they will then solve many of the problems that exist in education systems. So I think probably something a bit more systemic, but at the same time, developing teachers' kind of digital competencies, their digital literacy or data literacy, as it was described in an event I took part in a couple of weeks ago. These all seem to be really important components of this wider landscape too. And my view would be that we all need to busily get involved in it in order to shape the kind of future we want as educators.